live on our LinkedIn and YouTube channel of Recro. So if you want to share this to any of your friends who want to attend it in the last minute, if they did not register for the webinar, so you can just share the live link. So we're also live on our LinkedIn and YouTube channel of Recro. So please do share your name and where you're from, which part of the country you're from, and what made you really excited for this webinar today. And we'd love to see where our audience is coming from, and also for the people joining us live, please do and let us know your name and which part of the country you're from, what you're working as, which company you're working with, and what something that made you excited to attend this webinar today. Just one more minute, and then I think we'll go live with an amazing panel that we have today with another amazing topic, which Recro Talks. Okay, I think we can get started. We'll not make people wait more for the people who are actually on time. And yeah, we already have like 80 to 90 people watching us live on LinkedIn. So I think we can get started, Rishabh. And we'll already have people joining in, and will not make people who are on time to wait a little longer than this. Okay, so hello and welcome everyone. Hope you're keeping well and staying safe. This is Hafsa Anjum, and I am working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network, and grow professionally. So those who don't know about what Recro is, it is a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as CureFit, Udaan, Swiggy, Dunzo, etc. So welcome to Recro Talks again. And today we are having a very exclusive webinar on scaling Node.js applications. And our guest speaker for today is Rishabh Kajragi. And he's an engineering manager at astronomer.ai. Rishabh is an engineering leader experienced in building and scaling products for some of the fastest growing companies like Udaan, Yellow.ai, and Exio. Backed with rich industry experience and a strong education background, he's from NIT Warangal and Indian School of Business. Rishabh is passionate about being the intersection of business and technology, solving complex scale problems, serving millions or billions of customers on high transactions throughout, and operational problems and enterprise software products. That's something that really excites him to work towards building onto something really impactful in the tech industry. So thank you so much, Rishabh, for joining us. You may go ahead and say hi to the audience.
Thank you, Hafsa, for the introduction, and thanks to the Recro community, the audience, for making the time today to attend this webinar. I'll try my best to make it as fruitful as possible. And yes, the goal is to keep it interactive, hopefully to have fun on a weekend. So yeah, I think we can get started. Let me go ahead and share my screen.
Yeah, just before we start, I would like to make some announcements. So you can post your questions in the question section for the people who are joining us on Zoom. So you have a Q&A tab on your screen. So please do post your questions in that tab and not the chat section, because we might miss your questions in the chat section, because that's for the informal conversation. And people who are watching us live on LinkedIn and YouTube, please do post your questions in the live chat itself, and I'll make sure that your questions are answered by the speaker today. And one thing which is really important for this webinar is you have to be interactive, and that is main thing that we are really looking forward to. So please do answer the quizzes that's coming along from Rishabh and the questions. And if you're having any questions, please do not shy away from asking that. And I think we'll have a great time interacting and having an amazing audience today. And we'll be rolling out the feedback form in between. So let us know what you really love about the session, or what's something that you're having a takeaway from the session. And keep your notepad handy, whatever you're learning from today's session. Please post it on LinkedIn, tag Rishabh, tag me, tag Recro, and we'll be more than happy to see your learnings from today's session. Yeah, I think we can get started, Rishabh. Can you share your
Awesome.
screen?
Yeah. Quick check, is my screen visible?
Yes, it's visible. Yes.
Awesome. So the topic of today's webinar is scaling Node.js applications. As straightforward as it sounds, yes, this is going to be a walkthrough as to what could be some good strategies to make use of when you're looking to scale your Node.js application. So I think I'll jump right in, and we'll start with a sort of a small trivia question. Yeah. So I'm just going to keep Node.js at the center here, and I'm going to put this question to the audience that give me one word that you can think of when you think of Node.js. How would you define Node.js? Maybe give it one word, um, and I'll just wait on the chat for some answers until I move to the next slide. Great, I see some good answers. IO event-driven, non-blocking, asynchronous, yes. Any more? I'll give it another 10 seconds more. Not for compute heavy apps, JS runtime environment. Good. Awesome. I think looks like we have a very well-prepared Node.js audience today. And I'm going to take the next slide where I'm just going to summarize Node.js before we move into the scaling part of it. That yes, these are probably the most defining words for Node.js. And just giving you a brief walkthrough and summary of what this means is we know that Node.js is built on the JavaScript programming language, and which is already familiar to most web developers today. But unlike traditional JavaScript, it runs in the browser. That runs in the browser. Node.js executes JavaScript code on the server side, which is through a runtime environment. So this means that developers can now write both client-side and server-side code using the same language, streamlining the development process. So one of the defining characteristics of Node.js is its asynchronous and event-driven nature. It excels at handling concurrent connections and I/O operations without blocking the execution of other tasks. So this in turn enables high performance and scalability, making Node.js an ideal for building real-time applications and handling heavy loads. So another aspect of Node.js is its single-threaded model. So you might wonder how a single thread can, handle multiple requests efficiently. But well, Node.js leverages an event loop that efficiently manages incoming requests and delegates tasks to separate threads, ensuring that the server remains highly responsive. By separate threads, yes, I know Node.js is a single-threaded model, but I will come to the point how we can use separate threads to ensure scalability. Coming to NPM, Node.js Package Manager is one of the largest package managers out there, and it's a very integral part of the Node.js ecosystem. You have built-in capabilities to inform packages, right? Whether it's a request library, whether it's a logging library, whether it's a security library, you have it all in NPM. So, and they're all open source. So you have over 1 million open source packages available, which overall empowers the developers by providing a vast array of pre-built libraries and modules. So the extensive collection of these packages also allows developers to leverage existing solutions and focus on building their application's core functionality. And last but not the least, Node.js is very well suited for the microservices-based architecture, where applications are divided into small independent services, thanks to its lightweight nature. And each microservice built with Node.js can be deployed and scaled independently, allowing for greater flexibility and ease of management. So yeah, I think that probably summarizes our Node.js theory. And I'm going to walk through a couple of case studies as to which are the popular companies out there that are using Node.js. And I think we have a couple of very famous companies and big tech companies in this list, starting with Netflix, and how Netflix took the call to move to Node.js. Now, Netflix is a leading streaming service, right? And Netflix requires a platform that could handle a massive number of concurrent connections and deliver real-time updates, right? I think their unique selling point is having no lags in video streaming, right? And you need a very efficient infrastructure and backend service to support that. So by migrating to Node.js, so Netflix achieved this improved scalability and reduced response time, and hence also enhance developer productivity. And overall help build a lightweight and highly performant API layer, right? Which resulted in a 40-minute startup time reduction to 1 minute when they transition from Java to Node.js. And then we have PayPal, one of the largest payment systems out there. And, again, PayPal experiences similar problems with their Java-based environments, and they struggled handling the sudden increase in demand, and also there was this high need for real-time updates, right? So with Node.js and with the asynchronous and event-driven nature and capability of Node.js, PayPal was able to leverage those factors, and hence make their overall system more real-time. Help support real-time notifications when there was a time when the mobile era was exploding. So yeah, I think Node.js also significantly improved their scalability and allowed them to hence respond to changing business needs with its very flexible, way of the way Node.js is built. Then we have LinkedIn, where almost 57% of the unique users of LinkedIn are on mobile, and hence they decided to build their entire mobile stack on Node.js, right? To help deliver dynamic, responsive web experiences, while at the same time handling high volume of data intensive requests. So, and through that, they were able to achieve a high level of optimization, high level of scalability to support almost 930 million scale of unique members. We also have GoDaddy, which use almost 10x fewer servers when they transition to Node.js, and they reduce the time to first byte from 60 milliseconds to almost 12 milliseconds. I will be explaining time to first byte in the consequent slides. And obviously, we have a couple of other labels as well, like Uber, Walmart, even NASA, and we have Mozilla and Citibank. Right? So overall, we know that Node.js is a pretty big thing out there, and it's highly popular, it's highly scalable, and it's still relevant. Nobody's replacing it anytime soon. So it forms a very strong use case for using Node.js as our application for application environments. So diving into scalability, right? So to read a definition by Gartner, scalability is the measure of a system's ability to increase or decrease in performance and cost in response to changes in application and system processing demands. So what this means is, whether we scale up or we scale down, we're always looking at matching performance with the intensity and the scale of the usage of the system, right? We want to ensure that the performance is the same level of performance what we have at the scale of a single user on a single server on an application running on a laptop should be the same at the scale of a billion and million users, right? And that's the meat of the discussion in today's webinar. And normally, scalability or resource scalability bottlenecks come around the 4 displayed resources, which is starting with your CPU. Then you have your memory. You have your storage for storing your data. You have the network for handling your traffic. CPU is for basically your computation. Memory is for your caching layer and other I/O and intensive operations as well. So now, when we think of scalability, we have 2 types of scalability, right? I won't be diving too deep into this, but it's just a recap. So we have a vertical scaling model and we have a horizontal scaling model. In vertical scaling model, we increase the size of these of the resources listed in the last slide, which is your RAM, CPU. We just bump up the RAM from maybe a 32 GB machine to a 64 to 128 GB. We bump up the CPU from 8 cores to 32 cores. We bump up the database size from whatever 1 TB to 5 TB depending on your needs. So that's vertically scaling your individual resources, right? You're increasing the upper limit to what it can hold. And then we have horizontal scaling, where we're just replicating the same instance multiple times, right? So we have a single server node that's maybe running a 16 GB RAM, 1 TB storage, 2 vCPUs, and we just sort of replicate that across let's say 5 or 10 or 15 cluster node cluster environments. But horizontal scaling in general is reliable because it addresses single point of failures. It addresses high availability, but it's observed to be a bit more expensive. So we would rather start attacking the scalability problem by making it more optimized and performance optimizable and vertically scalable first. Basically, making maximum use of your available compute and storage and disk capacities. So, yeah, to summarize, scalability refers to an application's capacity to manage an increased workload without compromising its performance. And the response time also for a user request should remain consistent, even when the number of concurrent requests increase, right? So I should not see any difference in the response time, whether I scale from 10 users to 10,000 users. That's the robustness of the system we should be building in terms of scale. And also the app backend infrastructure should be able to handle this high traffic without experiencing any latency, right? So moving to on horizontal scale again, as I said, it involves adding more, just increasing the number of replicas of your individual unit, right? It doesn't actually involve bumping up the capacity of your hardware, but it rather involves adding more hardware resources, right? Such as server data centers to an existing resource pool. And now horizontal scaling is much more easier with technologies like cloud, Kubernetes, which offers you auto scaling capabilities. So you can just build your app and deploy it on cloud, deploy it on a Kubernetes cluster, and turn on horizontal pod auto scaling, and you have your horizontal scaling without much brain and without much thinking. You can easily horizontally scale. But I think where it hits you when the cloud cost starts coming. When you start seeing the bill, okay, you see a lot of cloud costs, and then you sort of wonder that how can I optimize the horizontal scale, right? And that's when you start diving deeper into vertically scaling a particular node or maximum utilization of current compute that's available. So so moving on to vertical scaling, which I'll be diving a bit deeper into, is it's also called scaling up and involves increasing the resources allocated to a single server or instance to enhance its capacity and performance. So in the context of Node.js, vertical scaling typically focuses on maximizing the capabilities of a single server to handle a higher load, right? So how can we make a single server manage a load of 1,000 requests to 100,000 requests, right, without actually horizontally scaling it? So the key areas which we generally consider in terms when we are talking about vertical scaling is CPU and memory, right? So by upgrading the server CPU or adding more memory, you can enhance the processing power and memory available to the Node.js application. So this can help you handle computational intensive tasks, right, and accommodate a large number of concurrent connections. And another aspect of vertical scaling is optimizing the Node.js runtime environment, right? So this involves using fine-tuning mechanisms like garbage collection, adjusting the thread pool size, the memory limits. And another very, very important aspect is the use of caching, which I will explain a bit in detail with an example in the next slide. But to summarize, caching is another technique that can aid in vertical scaling. So by implementing caching mechanisms, um, famous caching tools are like Redis, Memcached. These are basically in-memory caching. You can offload a lot of repetitive tasks or static requests from your Node.js application, basically making it more lightweight in nature. Another very crucial component of vertical scaling is load balancing. Knowing that Node.js is operates on a single-threaded model, it basically means that it can only utilize one CPU core at a time. So let's say your system is running a 8 vCPU or 8-core machine. You're actually the 7 cores are not going to be utilized or are going to be a waste of a resource if you don't use the right load balancing capabilities that Node.js has to offer. So Node.js has built-in modules or NPM modules like cluster, and it also has a more production friendly tool called PM2. So I'll give an example with some code how we can use the cluster module and PM2 cluster. So I'm running a 32 core machine. So let me actually dive right into the code. So I have 2 files here. One is without cluster.js and with cluster.js. So this file is doing a very simple computation. It is I've exposed an endpoint called /heavy. This app is running on port 3000, and basically it runs a for loop up to 5 million, up to a count of 5 million to just increase the total variable and just finally send the output of the total variable after the for loop ends. So I'm just going to run this one and see what do we have here. So I'm just going to run Node without cluster.js. The prerequisites for this is just an Express server I'm running. So simple npm install of Express should get you running on this. So you see this app is listing on port 3000. So the server is ready. Server is running. Actually, let me put this one and run it on this one. Okay. So let's quickly test this endpoint. Yeah. So we see that the result of the CPU intensive task, which is on line 13, it's throwing back the total variable, which is 5 million. So now this is the file or the code for without a cluster. And I'm going to run the same with the cluster and see what happens, right? And I'll walk you through the code that's happening here. So we are using the cluster module. We're using the OS library to get the CPU count. And we are basically pointing to the module that's defined inside the without cluster.js. So that's why I'm using dir name and file URL to path to point to the exact location of the file. And what I'm doing is I'm logging the total number of CPUs. I'm also logging the primary process ID. This process will be running in. And I'm using the count of the CPU to basically fork fork child processes based on the number of CPU counts we get. And on when the job is done, the process exits and we kill the process and then we start another worker accordingly. So let me run this one. Stop this server and run Node. Let's do that here. There you go. You see that a primary process has been created with a primary PID 863, and the number of CPUs is 10. And since the number of CPUs is 10, we have, using the cluster module, basically spins up 10 different child processes. Rather 9 different child processes and 1 primary process. Right. So we see what the cluster module is doing here, but now how do we test this, right? How do we see the performance? So I'm going to be using a load testing tool. So let me go ahead and run without cluster.js, run some load testing, and maybe grab some results and see what's happening. Yeah. So I'm going to run load test. So it's going to spawn 1200 requests to this endpoint and 200 concurrent requests at a time. And we're going to be hitting this slash heavy endpoint. So let's see what do we get from this. So you see it's hitting, it's taking some time. It also tracks the number of errors that can encounter while hitting this request. And overall, it gives you a statistic, right? So target URL is the endpoint what we're trying to target. The max request is 1200 and the concurrency level is 200. So it sends 200 requests at a time. Total completed request 1200. We did run into some errors, but we see the total time is around 12 seconds. Right? And the requests per second is 97 requests per second. The mean latency per request you can see that around 1800, 1886.1 ms. Right? So what I'm going to do is now I'm going to run the cluster module. We're going to record this number. So I'm going to just record the total time and the mean latency. So 12.4 and 1886 is with one CPU core. I'm going to stop this process. I'm going to run Node with cluster.js. We have our cluster up. And I'm going to run our load test tool again. That was quick, right? So we have total time of 1.7 seconds from a reduction of 12 seconds to 1 second, just utilizing the same machine. On the same machine, just utilizing all the resources to run this and not just one. Right. So we see our mean latency is reduced all the way to 261.6. Yeah, so this was a quick demo of how we can solve the single-threaded nature of Node running on a multi-core CPU core server by utilizing all the CPUs at once. So we should be very mindful that when we are doing vertical scaling, we should only scale when we have completely optimally used the resources available in our system. That's what we are doing here. So if you see the illustration here, on our first machine, we have the node process running. We have just one node process. And for example, we have 4 CPU cores, but we have just one CPU core that is in use due to the single-threaded nature of Node.js. What we do is we use something like PM2, a cluster module. And now we have all the 4 CPU cores in use. And basically, this acts like a load balancer. It spawns 4 different node processes and handles the requests between these 4 processes. So moving on to, yeah, so often when we develop Node.js code, we often we often don't look through the cracks, right? And looking through the cracks means that we need to understand that have we written the most optimized code or not. And generally, when you're building, you look at optimization right at the end. We don't build code. We don't build code right away to optimize. We normally optimize when we hit scale. So we're assuming that, yeah, our application has hit scale and we need to do some application level optimizations. So how do we address this? Right? So to start with, the best way to do application level optimization is that you need to have the right metrics and data points in your hand to understand where exactly you need to make code optimizations, right? So a very common practice before deploying to production, or rather before, even after developing a feature, we have a load testing process in place, right? Where we load test using tools like Apache Bench. We monitor the CPU utilization, the memory utilization, the event loop utilization, and basically we need to spike the usage until it breaks, right? We got to hit it keep hitting it until the entire thing breaks. And that's when we know that we have hit scale and we need to sort of optimize, scale up, scale down, optimize based on how we want to attack the problem. So in this case, we want to attack the problem that, we have spiked the usage. Okay, we have our system, breaking now. Let's start with, optimizing our code. Let's start with how we can do there. And then we can we can optimize our resource consumption. And when we have that set, all that, then finally all we need to do is maybe set some high availability and keep the server on an auto scaling mode. So I keep horizontal scaling as the last strategy. I want to attack this as a vertical scaling problem and an application level optimization problem. So yeah, so we load test, monitor, spike the usage until it breaks, fix the bottleneck, monitor, rinse and repeat. And very popular tools available are Prometheus and Grafana for gathering metrics, node metrics, and also for profiling. So yeah, a very funny way to put this, but what we are trying to do here is we are protecting the event loop, right? We want to make sure that the event loop is not clogged at any point. The event loop with queue is freely running, task in, task out. We don't want one particular task long run. We don't want any long running task or a blocking call, so such that we don't have space and the capacity to handle the other requests. Now, how do we do that? There are certain strategies I'll walk you through. Obviously, the list is not exhaustive. There are a lot of strategies you could follow, but I could start with the most common ones, right? So, starting with, yeah. So this is an example of how I normally capture node metrics in my applications, right? I make use of Prometheus to send data from the node server to Prometheus, which is a metrics database, and then using Prometheus queries, I create Grafana dashboards. So here you can see the process CPU usage, the event loop lag. This is a very interesting metric, the event loop lag, right? At what point have you reached a spike where the event loop is lagging, right? And you can also additionally add dashboards to even track which requests are causing the event loop to lag. We have the process memory usage, active handlers, request total, and the heap, also measuring the heap size and the heap availability. So starting with a couple of strategies, the most simplest one is, as much as possible, use asynchronous functions. One of the primary areas of focus for application level optimization in Node.js is asynchronous and non-blocking IO operations. And the fact that Node.js excels at handling concurrent connections and performing IO tasks efficiently, we need to make sure we are leveraging the use of callbacks, the use of promises, the use of async await, to make sure that your application is not blocking the event loop and remains responsive to other requests. So this is a very simple example of how we are using fs.read file, how we are using fs.read file over fs.read file sync to make sure the file read operation is a non-blocking call, right? So, and other IO operations can include processes which perform read and write data operations like this one. It can be database, cloud storage, or basically any other local storage disk on which the IO operations are performed. So the read file sync is a synchronous call, and it blocks the execution until finished. So what it means is that it's going to stay on that line. It's going to the flow of control is going to stay on fs.read file sync until the file storage contains are read and loaded onto the memory. Whereas read file is asynchronous in nature, right? It's going to execute the operation, and Node.js is going to be like, what, you run this, I'm going to be keeping you running, but I'm not going to be blocking any of the other tasks that's coming to me. And how we know that the file is completed or the operation is completed is through a callback function, right? So you pass a callback function. Here we are passing, we are just console or logging the file, right? And also we are catching any errors in the process. So this part of the code here is our callback function. This triggers once the read file operation is over. So you pass a callback function which gets called when they finish, and that's how you optimize using you have performed a level of optimization using asynchronous functions. As much as possible, use parallelism in your code, right? We did see an example of parallelism using the cluster module, but we can also use async.parallel to parallelize tasks defined within your code, right? And the end objective is to reduce your latency and minimize blocking operations. A very, very important point is caching, right? Caching is absolutely necessary when you're hitting scale. And I would like to see a system design in place that doesn't have a cache component in its high level design. And I'd probably not find any system design if you're actually designing for scale. So caching is a very powerful optimization technique. And by implementing caching mechanisms, you can basically store frequently accessed data in memory or an external cache store. Right? A very popular caching tool, Redis, is an example here. And basically, you're reducing the need to fetch data from the original source repeatedly, right, by maintaining a cache. And hence, you're improving the response time, and hence also you're reducing the load on an application and external resources like a database. Another important point is when you're at scale and when you have a lot of data you're loading onto your client, and also if you're using even if you're using strategies like server-side rendering, it's good to use a CDN, which is the content delivery network, to basically reduce the time to first byte, right? So the time to first byte is a measurement used as an indication of the responsiveness of a web server or basically any other network resource. So it measures the duration from the user or client making an HTTP request to the first byte of the page being received by the client's browser. Right? So if you see this diagram over here, by placing a CDN here, we are reducing the time a request is made to maybe fetch an image, right? So step one, if you see, it tries to access this URL here. Based on the CNAME of the CDN, it checks whether this object is cached. In case it's a cached object, you return it directly. Otherwise, if it's not cached or expired, it goes to the origin server, then caches the object, and then it returns the image back to the client. Right? So you see an overall reduction of the time to first byte or response time by using a cache at scale. And the next point would be using of HTTP2 over HTTP. So I've seen very few people have this knowledge of why HTTP2 trumps over HTTP. And I'll try to explain these 4 points in as briefly as possible. So the use of multiplexing, which is one of the significant enhancements in HTTP2, which basically allows for concurrent requests and responses over a single connection. So if you see using this diagram here, in one TCP connection, I'm making requests for rendering these 3 files on my client. Right? So HTTP1 earlier had to wait for each request, and basically there was that wait time added to the overall response time. Hence, before initiating another request. Hence, basically leading to a delay, right? So with the whole multiplexing feature in HTTP2, we are using the capability of concurrency to handle the request in just one TCP connection. Header compression basically means is, so in HTTP1, headers are sent with each request and response, resulting in redundant data transmission, right? So in HTTP2 utilizes a more efficient header compression algorithm called HPAC, and it compresses headers before sending them over the network, and uses a technique called header table indexing to further reduce the redundancy. So overall, this reduces the overall amount of data that's transferred and improves the network utilization and overall enhances the performance. We have a concept called server push, where HTTP2 introduces server push that basically allows the server to proactively send additional resources to the client without waiting for explicit requests. For example, the server sends an HTML file, it can also push associated CSS and JavaScript files along with it, basically eliminating any need for the client to request for them separately. This example also explains the same using multiplexing, how we are sending jQuery, a JS file, a CSS file, along with maybe it's just HTML and some images. Right? So overall, there's a reduction and increase and faster this faster page loading due to this, right? And yeah, I think the binary protocol is also another way of how we can optimize the network requests using the binary protocol. So yeah, I think to sum it up, there are various aspects of addressing scalability problem in Node.js, right? But this particular webinar was more focused on how we can do application level optimization and optimization of the resources available to you in hand to make sure that your Node.js application is performing at peak and at the most optimal configuration. Right? So yeah, I think this brings us to the end, and I'm happy to take some questions.
I think we do have a question in the chat from Vivek. So he's asking, choosing HTTPL2 or HTTP from front-end side, or is there anything we have to do with Node.js?
So we have different modules available on the front-end side to basically use HTTP2 over HTTP. It depends on the nature of the request you want to make. So request is from the client to server. We have front-end packages to address the same, where you can make changes in your headers, the headers that you call to your server. So yeah, it's again depends on your use case.
We do have a question in the Q&A tab to show, and that is Node.js versus Spring application areas of Node.js with a question mark.
Yeah, so I think application areas of Node.js is very, again, knowing the nature of Node.js being its asynchronous and event-driven, it makes more sense to have it in especially web applications, because one of the biggest pain points in scaling applications is, also scaling engineering teams, is that if you have both the front end and back end in JavaScript, you save a lot of time and effort. And overall, Node.js, the way it's designed, it's more friendly for web application and event-driven architectures, where with the nature of our applications today, mobile or web, and data being real-time in nature, you have the concept of push notifications. It makes more sense to use Node.js. But again, if you're looking at mathematical heavy operations, Node.js is not the right tool to use, because you want to do anything to avoid any blocking calls, right? Whether we don't want to do any CPU intensive operations with Node.js. Spring Boot is also very excellent for developing enterprise grade applications, but I think it ultimately goes to also specific use case. You cannot exactly say Spring Boot is better than Node.js, or Node.js is better than Spring Boot. It applies to what use case you want to use your programming language for. So highly event-driven architecture, event-driven applications, Node.js would be the better choice. Also, if you have a lot of customizations in terms of due to the availability of libraries and npm modules available, Node.js wins there. Even the time to spin up a server, the fact that it has the hot reload functionality, overall there's a huge reduction of developer efforts as well when you're developing Node.js at scale. But yeah, so I think it's very, very specific to what use case you want to design your application for.
Okay, we have one more question. While deploying Node.js containers has a pod in K8s, what is the max UP limit, max memory limit would you recommend to set?
I'll need more data to answer that, but it depends on how you want to design your design the scale of your application, right? So yeah, like based on the number of how many concurrent connections your application is going to be serving, right? Based on that, you know that how much CPU, if you do the right profiling, you know how much CPU utilization will be required, and based on that, you can set your limits and requests in your Kubernetes manifests accordingly. So yeah, it's very subjective to how you want to design, what scale of design you're looking at.
Okay, I think we have a follow-up question to it. I've heard Node.js can face memory limitations. Is it true? If yes, why is it, I guess? Yeah.
Sorry, could you repeat the question?
I've heard Node.js can face memory limitations. Is it true? If yes, why? What could be the reason? Yeah.
I need to click on this one. Yes, Node.js has a memory management as a strong use case when it comes to facing bottlenecks. Right? So we can see if you had seen from one of the slides where we saw the heap usage, it's possible that we would reach spikes in our heap usage, due to which we know that there are a lot of there are a lot of dangling requests or garbage collection that needs to be done in place to clear the heap. Yeah, so again, it depends on your design, the design of your application, design of your code. If you don't use the right optimization techniques in place, if you use more blocking, if you don't make use of the non-blocking nature of Node.js, you can run into heap limit exceeding and space not clearing for new requests to take place. So yeah.
Yeah, so we also have a question from Naveen, and he's asking how to handle WebSockets with cluster module.
Can you be a bit more specific?
I think, Naveen, you have to be a little more specific about your question. I think we'll be able to answer that. And then after that, we have, if you are hiring a Node.js backend developer, what would you look for in the candidate as an engineering manager? Yeah.
So I think I would say at least basic proficiency in JavaScript, but although I don't look at having prior particular programming language experience, I would just say that I preferably see the fundamentals of the engineer is strong, because if you're learning any programming language, it all has to do about how that programming language is enabling you to utilize your resources efficiently, right? How we're using, why you need to use Node.js, why basically are you using Node.js to solve what problem or build what microservice. So I think, yeah, maybe a base level of definitely I would say past programming experience, base level of JavaScript would be a added incentive. But I would rather see a basic understanding of how Node.js works, understanding what the event loop is, the theory behind asynchronous, non-blocking, event-driven systems. And I think that clarity should be good enough.
Okay. Then we have, what are the common bottlenecks in Node.js applications that affect scalability?
Yeah, I think I gave a couple of them in the slides, but yeah, I'll maybe list them out again. So So common bottlenecks that can affect scalability is again, this can be at the application level, this can be at the resource level, right? So if you have to look at resource level scalability, one clear example was that you're not making full use of all the CPU cores available in a single machine. So that can be a bottleneck in terms of um, we are trying to address the scale by adding more resources or adding more nodes, which is horizontal scaling over vertical scaling. Other common bottlenecks can also be on the application level, to be specific, that you have you're using wrong practices that sort of choke the event loop. You're not making good use of asynchronous functions, callbacks, promises, due to which the event loop is blocked and is not able to take more concurrent tasks. Other bottlenecks can also be again, the time to load the first byte, as how we can optimize loading the first byte on the client when a request is sent to the server. So that is more of a caching bottleneck. So I think overall, to put in plain vanilla, right? We are just trying to optimize 4 things. We are trying to optimize the CPU. We're trying to optimize the memory and handling traffic, which is your network, and your storage. Right? So storage, I did not focus too much on storage today because storage is very cheaply available today. But whenever anyone looks at optimizing resources, you always start with the CPU because those are the most expensive functions.
Okay, so we have a few questions from the people who are joining us live, Rishabh. And meanwhile, people joining us on Zoom, if you guys are having any questions, please post that in the chat box. So let's go with the questions that we have from the live viewers of LinkedIn. So the first question from Manav, and he says, what type of Node.js applications are we going to scale, microservices or monolithic? Okay, I think that was for the beginning of the webinar, I guess.
Okay.
Yeah. And how did PayPal think of moving to Node.js would handle more requests? So that was another question.
So PayPal basically, I mean, there's more details available on the internet, but all I can summarize is that they wanted to make their application more event-driven friendly, right? Knowing that they were a web-based payment system, you need to make sure that your requests, being a payment system, you need to make sure that any requests that are made, any traffic, that should be with the least latency and and the fastest response time, and as real time as possible, right? And leveraging that asynchronous and event-driven capabilities to process payments faster and provide real-time notification was the core essence of why PayPal moved to a Node.js driven architecture. So yeah, that significantly improved their scalability, right? When they started hitting scale, and with the changing business needs and the nature of how they wanted to build their platform, that's why they took a call to move to Node.js.
Yeah, and next question. It's from Piyush. So that's a little controversial question. And he says, sir, Node.js and React use nahi hoga kuch dino baad because of AI. Is that true?
I think it's too early to say this. I would say Node.js, React, they're not going anywhere. I think probably every application out there, at least every front-end application built today, even the largest companies use a JavaScript framework, whether it's React, Angular. I think React is the more popular one today. And the same with server-side, right? Node.js. So if you have huge systems powered by Node.js and React, you're going to be maintaining this for a while. And until then, you're not going to see Node.js or the adoption dying away very soon.
Yeah, and another one. How can we optimize or fast Node.js applications if we follow microservices architecture?
I'm going to repeat that question. How can we optimize fast-moving applications using a microservice architecture? Is that correct?
Yeah.
Yeah. So that's a good question. So I think that's where when you're looking at a microservices architecture, you're probably looking at a lot of business functions, right? That's how I like to see microservice architecture. You have a different service for a different business function. And when you're trying to scale a microservices architecture, it's that the first thing you want to look at is you want to avoid any sort of single point of failure, right? You want to make sure these are reliable and highly available. So I think the first thing you want to design is that are we addressing these two factors, that it's highly reliable and highly available? Because these different microservices are so interdependent in nature, you would want them. You wouldn't want a cascading effect if one fails and the other one is not able to work due to a dependence. So I think that's how I would start with looking at whether it's addressing this, and then just again go through the runbook of going to each service at a code level, application level, doing the necessary optimizations, and and also make sure that you have the necessary components in place that helps you scale a microservices architecture. Like you have caching mechanisms, you have load balancers, you have reverse proxies, you have databases, database replicas, which is the very standard vanilla system design sort of set of components which you normally look at.
We have one more question, Rishabh, and it is, what are some best practices for database scaling in Node.js applications?
I think database scaling, it has to start with the use case of how you want to store your data, right? And what kind of data you're looking at we're wanting to store. Again, the two main sort of types of databases that come to mind are NoSQL and SQL databases. Where SQL databases are used for more transactional type of data, and NoSQL databases are used for more object JSON object or object store oriented data, where based on the dynamic nature of the data you store, you sort of choose what sort of database you want to go with. So it starts there, right? It starts with defining your use case, defining the right use case of storing your data and what type of data you're trying to store. And once you make that choice, then it's there's nothing specific to Node.js. I would say it's database scaling strategies apply to every server technology out there, and you have the standard optimization techniques like indexing and avoiding single point of failures, having replica sets in place. So yeah, I think it's the answer varies depending on the use case you're trying to adopt here.
Yeah, I think one last question from the people who joined us live, and is, how can you implement microservice architecture to scale a Node.js application into a modular and distributed system?
Okay. So again, this is adopting a microservices architecture should start with the need, right? You don't build for a scale of 10 users and build 10 services. So it doesn't make sense. So the microservice architecture can sometimes be an over-engineering or overkill, but when you know that you're hitting a scale, you have multiple teams managing these services, then it makes more sense to build microservices build architecture. And yeah, in Node.js it's more common because the sheer fact it's so event-driven in nature. You can have a different service for every business use case you use. So the common strategies to scale microservices architecture is, you can use the traditional, where you want to it's the DevOps part of it. Like, how do you want to host your application environment? Do you want to use the traditional cloud VMs, or do you want to use something like Kubernetes? So I think Kubernetes, I would say Kubernetes has been a very popular choice in scaling microservices architecture lately, because purely of its customizability it offers, and the fact that you're using multiple containers, multiple environments in the same underlying operating system. You don't have to have a new virtual machine for every application server. So yeah, so that's the horizontal scaling factor of it. And in general, you have other components that come into microservices-based architecture, not just your application servers, but you have your database servers, you have your cache layer, you have your load balancers, application level as well as network level. Yeah, so I hope I answered your question. If there's a specific use case you would like to know, like, happy to answer that as well.
Yeah, I think we have one last one from Naveen. He's actually joining us on Zoom. So, as worker threads have become stable in Node.js, so what is the difference between a cluster module and worker thread, and when to use cluster or worker thread?
Worker modules have become more stable. Could you please elaborate?
Okay. How to secure microservices? Is it needed to make secure if we use? I think we had that question already, right?
Securing microservices.
How to secure microservices? Is it needed to make secure if we are using K8s and not exposing anywhere, just using for internal communication?
Yeah, I think security depends. Again, depends if you're using it for something like internal, then you have a Kubernetes cluster running on a virtual private cloud that should sort of the cloud should take care of the security in that case. But it depends on if you're exposing any of these services outside, then you'll have to have different security practices in place, and that can start from all the way to the application level and can go all the way to your load balancer, right? And what sort of network security policies you're looking at, or pod security policies you're looking at. Kubernetes sort of helps customize that part of security, has a well-defined way of customizing that part of security. So yeah, I hope that answers the question.
Yeah. I think that was the last question. I think we can stop the presentation, Rishabh.
All right.
Okay. One more minute, guys. If you have any more questions, please drop in quickly. But then I think most of the questions were answered by Rishabh, and I think we can. Okay, so that was the last question, and that brings us to the end of this wonderful discussion. And I would like to thank each one of you for joining us. Hope you learned something new from today's session. We will look forward for your post on LinkedIn along with your key learnings. Don't forget to tag Recro, tag Rishabh, tag me in your post, and we'll be more than happy to see your learnings and takeaways from the session. And also, thank you so much, Rishabh, for joining us, and thank you so much for taking out time and sharing such insightful information. And in that, for taking your time out at the weekend, we really are honored to host you today. And we actually had the people's reaction on LinkedIn and everywhere, so people loved it. And if you want, people watching us, if you guys want more advanced topic on Node.js, let us know, and we'll be more than happy to have Rishabh for more sessions. So before we end this session, we have few announcements to make. So we have created a community for developers called Rebase on Discord. Join our close community for Java, for front-end, back-end folks to unleash your true potential. So the link of the community is in the chat. And let me share that again. So you can connect with mentors from amazing companies who are working over there. And we have people from 2+ to 18+ years of experience, people over there. You can get mentored, you can ask for help or have a career guidance over there. And yeah, you can connect with the like-minded folks. And we have also, I've also dropped a feedback form in the link. And please drop your learnings and what were your takeaways from the session. And if you want to show for another session, please drop your thoughts and feedback over there, and we'd be more than happy to hosting for another advanced session on the scaling of Node.js. And if you have more questions, you can also connect with Rishabh on LinkedIn. He is pretty active on LinkedIn, and he'll be more than happy to connect with you if you're having any questions regarding the webinar that you are part of today, or if you have any other questions regarding some career or anything that specifically on the Node.js, you can connect with him, and he'll be more than happy to help you guys. So if you're exploring career opportunities, Recro is hiring passionate developers. Check out the current openings at Recro on recro.io/careers. I'm actually sharing the link in the chat. So if you or your friends or your colleague are looking out for a change, so we'll make sure that we place you in the A-grade startups of the country. So to stay updated with such events, follow us on social media, follow us on Instagram, LinkedIn, and YouTube. And yes, the recording of the session will be out in 2 to 3 days, but then you can still have access to the live of the session that's happening today. So you can either go to LinkedIn Live or go visit Recro YouTube page, and we'll be live over there. So if you missed out on any things during the session, please go check it out again. Or if you want to share the same thing with your friends and colleagues, you can watch the live by the time we can actually upload the proper edited version of this webinar. Yeah, thank you so much, Rishabh. Thank you for joining in. And I hope you had a great time.
Thank you, Hafsa. Thank you, everyone.
Thank you so much. Have a great weekend, guys.